Perfect. So I hope everyone had a good lunch, right? Okay, perfect. So I am here to take a session on secure coding practices. So let's begin. So a bit about myself. This, I guess, covers everything there is to know about me. I am a programmer since the past almost 20 years. The first programming language that I worked on was Logo. A show of hands, anyone heard of Logo? Nice, right? Turtle? Yeah, I loved it. So I think that's what got me into programming. And I've recently begun to do a little bit of research and experiments on ethical hacking. So I do a lot of stuff around that. And I love my coffee, as most hackers generally do. Hackers and programmers, you generally won't see me without one, right? So that's about context that I'll set. Right. So let's move on. I will first touch upon why we as programmers need to write secure code. We as architects need to architect software properly. And I'll touch upon OWASP Prop 10. I'll give a couple of demos of some some very common vulnerabilities. And then we look on how we can secure stuff and follow some basic security practices. So as somebody who's into cybersecurity for some time, I know it's a little hard for people to get into cybersecurity. So as somebody who's new, it will be something, I'll be very basic about stuff. So I hope it will be easy to relate to. OK? Moving forward. So why? Why do we need to write secure stuff? You may have some very cool stuff built on some very modern tech stack, deployed on very recent hardware, Docker, Kubernetes, etc. But all it takes is one chink in the armor. One small hole is all an attacker needs to exploit. So as you can see in the image, an XSS or a SQLi is all that it took. It's one chink in the armor. And the results can be catastrophic. You can lose access to system, to all your servers, all your production servers. That will definitely lead to operational downtime. That will lead to endless hours of debugging and making sure and trying to resolve all those issues. Obviously, it may also lead to financial loss. That can be direct or indirect. Direct can be somebody gaining some critical credit card information, for example. Indirect can be something you lose your brand value, your customers are irritated at you, and they end up not going with you. That's an indirect thing. And last, lawsuits. That's very common with different compliances that are in place to make sure that people keep their customers or end users' data secure. So as we have cleared up why it is important. So we look at OWASP Prop 10. OWASP is the Open Worldwide Application Security Project. It's sort of like a non-profit sort of organization which does a lot of cybersecurity research. And the best part about it, it creates a list of the most critical and common security risks to all applications. So they have two lists. One is for catering to web applications, and one is catering to API security. So for the purpose of this session, we will be sticking to web applications. So the current list that I think was released in 2021 has all of these, and we'll be covering most of these in check. So the first one, broken access control. So that essentially means that whatever data that you have, whatever resources that you have, attackers are able to access that, or even legitimate users are able to access resources or data outside of what they have control over, what they should be accessing. So if you are familiar with least privilege, which is the concept where anyone should basically have access to the least amount of data and resources for them to be able to do their work properly. That can account for users, that can account for services as well. So this is a clear indication, clear violation of least privilege, right? And it's mainly due to missing access control policies, which we'll cover in a bit. The impact is that, let's say there is an e-commerce application, I can basically access profiles, shopping carts of other users. It can even account for escalation of privilege. That means I, as a normal user or even anonymous user, I can maybe gain admin access to the servers or data controlling the whole application. And I can even access unauthorized pages. Any 403s that you get, I'll be able to access them. Next, vulnerable libraries. That's actually fairly common. If you have heard of Log4j, any Java programmers out there? So there were a couple of years back, there was a remote code execution CVE that came out, where anyone below the version of 2.1.7 could gain remote access. Not remote access, but they would be able to execute commands on the server hosting an application that was due to the Log4j library, which is a fairly common logging library in Java systems. So that's an example of using vulnerable libraries if your application is hosting, is using those vulnerable versions, right? So next is one of the most common and most widely exploited ones. That's injection. So that means untrusted user data is sent to an application that can essentially allow the attacker to execute commands or exfiltrate data outside the system. So there are three common types. The first one is SQLi, and which is basically relates to executing queries over the database through some well-crafted payloads. Similar with XSS is cross-site scripting, where you're able to craft some payloads and exfiltrate data or execute some commands using JavaScript. And last is command execution, which is pretty dangerous, though it's somewhat uncommon, that using some payloads and untrusted user parameters, you're able to directly access stuff on the server hosting the application. So injection has some catastrophic impacts, such as leaking of privileged information and remote code execution. Okay. Let's cover a few the injection things in little more detail. SQLi. So if you can see the image, there are some crafted payloads. You can start out with a single apostrophe, and that'll lead you to believe that the application is vulnerable to SQLi. So this happens because application does not validate the user input, especially when the user input is directly correlating with the database queries. So the impact is information disclosure, and you can even, let's say, drop an entire database connected to an application. That is pretty severe in terms of impact, right? Moving on to XSS. These are just malicious scripts that can be injected onto websites. There are three types, actually. One of them is stored, where you are able to make sure that the payload that you put in an XSS input is basically then gets stored onto a particular server that is where you're executing the queries on. And one of them is reflected, where it all depends upon the user input. And you can do stuff like session hijacking and exfiltration of data using XSS. We'll be actually trying one XSS payload over here. So I'll touch up a little on the demos part, right? Command injection, like I said, that you can execute some scripts or direct OS level commands to using anything as simple as JavaScript. So that generally happens when you do not validate user input. And let's say you're opening up a file or so, then those can directly interact with the file system if proper checks are not in place. And it can cause remote code execution or privilege escalation. Right. Moving on, security misconfiguration. This is not something code related, but it's when you're setting up an application or setting up an infrastructure to host your application, then these things kick in. So let's say you're starting out a website and you host an Apache server, but you do not change any of the default settings, any of the default configuration. You keep all those simple file-related stuff. Then those are generally common information. So any attacker who's looking out for such stuff, they'll easily be able to get that information. And if there is a common vulnerability associated with that, they'll easily be able to exploit it. So one of the common things that happens is there are excessive permissions being assigned to the server host, to the service that is running your web application. So out of simplicity, people do end up running stuff as root. And that does end up causing a problem if the root credentials get compromised. Right? And the second common stuff is you host everything without encrypting your communication. You just run it on default standard unsecured port 80, and that's basically sends up all the communication in plain text. So even that can be exploited. Okay. Cryptographic failures. So one of them we covered just before is the lack of TLS. So that refers to communication with data at rest or data in transit. So TLS or SSL refers to data in transit. Second thing can be you do not encrypt sensitive information. You just leave it in plain text. And a very common example, which is surprisingly very common, is storing passwords in plain text, which should be a strict no-no since it's been known for the past 30 years, but it's surprisingly still common. And you do not use salting in your password hashes, or you use a very weak hash algorithm for your passwords, which can be easily broken by something as simple as John the Ripper. So impact can be leakage of your credentials, and those can be, you can find stuff on the dark web for any common credentials that may occur. Okay, moving on. Server-side request forgery. So this happens when your parameter, which is basically a user input, is what is communicating directly with stuff on the file system. For example, in this code that you see, it's a standard PHP code where you're opening a URL, and there are no input validations in place, and then you're sort of like opening a file associated to it. So I, as an attacker, if I know that there are no input parameters in place, I can just craft a payload, which will basically be any local file on the server, which can maybe result in leakage of information on that server. So example can be your passwd file. If I can just craft a payload where I put in the parameter as the location of that passwd file, then this essentially will dump out that information. So yeah, that's server-side request forgery. Now moving on to demos. So I have a couple of demos in place where we'll cover broken access control, and an example of that will be path traversal, and one injection, which will be XSS, and we'll be moving to session hijacking. Right? So let me open those up. So first, we'll move on to your path traversal. So I have a simple HTTP application. So there is, if you can see the parameter, there's a simple PHP file which is basically printing out something very similar to the application that we saw in the previous slide. So if I do this, there's nothing much which happens. But if I end up crafting a payload, it prints out all of this information. So you can see the permission sets and the users associated to it. So this is a very sensitive file, and the permissions associated to each and every file and each and every user, right? So this is, so I'll show you the code as well. Something as simple as that, where I'm getting the URL parameter there, file, and I'm just including that file. So it just prints out that complete file, which is a local etc/passwd file. Right, so there are solutions to it. And the solution is I just introduce a parameter called a way where I can have a canonical path, where if the base path, which is here, does not corresponds to this, then I will not print up the file. Right? So I will try the same parameter over here, and file not found. So the solution to this is just something as simple as input validation. OK? And next, I'll just move on to injection. So in this case, what I'll do, I have also hosted this. I have created a simple login form. Don't mind my CSS. I'm pretty bad at it, as it is pretty amply one. So it's a simple admin login page. And I just type in my credentials. And there's a search page. So my attacker mindset tells me that I will try something related to XSS or SQLi on this. So I'll just copy a very simple payload and try it here. So I'm also I'll first do it, and then I'll let you know. I'll just type in this payload here, and I'll submit it. Right? Nothing much that looks by the looks of it. But when I'm looking here, I see that I have sent this PHP session ID in an HTTP request to the attacker server. So what do I do with this? I'll just copy it. I'll open up another browser. I see here the same login form. I'll just modify the PHP session ID, and I'll try to access it again. And voila, I have admin access. So I was able to hijack the session of the admin user purely by the basis of the cross-site scripting, that payload that I did. OK? OK, so those were the demos. So let's move on. So yeah, that seems pretty bleak, right? It saddens me that something as simple as that, a simple payload, can have such dire consequences. Pepe is pretty sad about it. So there's a solution to it, and that solution is pretty basic. It's just following a set of basic security practices. There are 8 of them that we know. So first of all, validate user input. I cannot really emphasize this enough. There are way too many attacks that happen through improperly sanitized input or lack of sanitized input. XSS, SQLi, CSRF, everything is related to input. So if you're just able to manage that, then a lot of your headaches can go away. right? It's something as simple as that. So something as simple as regex for preventing C. coli, path reversal, or XSS, or restricting file uploads to just your own trusted servers. So that does help a lot. Okay. Heed warnings. So all programmers, any programmers? So your IDE, whichever one that you use in whatever language that you program on, a lot of them, most of them rather, they give you warnings that, OK, this code might be susceptible to it, to something, some CVE of sorts, some compiler or interpreter warnings. Like when you install something on Node.js, it does give you a list of packages and the vulnerabilities that they may be impacted by. So what we do, we generally tend to ignore them, or maybe handle it when your pants are on fire. Not really a good idea, right? So the concept is just to heed that warning, make sure to apply that in a patch, and have regular releases for security. Okay? Securely architect. So yeah, so this is more on the infrastructure level. You basically have to secure communication between all of your resources, whether it's your application server to any of your database, to the caching layer, to maybe any microservices that you have deployed, any Kubernetes cluster that you have. All of that communication needs to be secured. You need to basically have separation of all of your networks. You basically need to have all of your internal servers secured within a private network, and have all of the public-facing network just communicate with the private network, and just have that whole internal network secured. And role-based access control. So basically, that's on an authorization layer. Whenever there's a communication, whenever there's a need to access any data from any other service, you need to make sure that those services have the capability, the authorization to retrieve that data, to execute any command. All of that authorization checks need to be in place. Secondly, securely access all of your servers. You cannot just expose all of your servers, internal servers, to the public network. You need to make sure that you basically access all of those servers, those production level servers, from secure networks. Or if you can connect to a VPN, that definitely helps. Then you need to audit access. Whenever there is somebody who's trying to access some protected resource, you need to make sure that you have your auditing in place. So whenever there is an incident that happens, monitoring is the first level that you need to look at. You need to look at what happened, why it happened, where it happened, and how it happened. Because unless you know that, you won't be able to address it. And that kind of defeats the purpose, right? Because no matter how secure your setup is, you can still get breached. So I cannot emphasize enough on having extensive auditing, logging, and monitoring. Keep it simple. Simplicity in design is just perfect, right? As simple as your code gets. You'll easily be able to trace if any issue happens, where it happened, and how it happened. If you have a complex environment made just so that it looks cool, it doesn't work, right? If you just have it simple, it will always work. You'll be able to extend it. You'll be able to maintain it. And obviously, it helps in reviews and security tests as well. So all of your simple setups that you have, you can easily test out all the stuff. You can make sure that everything is top-notch. And yeah. Deny by default. So that maintains that whoever is trying to access a protected resource, they are an attacker. You have to treat them like an attacker, and make sure you deny access until they prove that they have access to do so. They are who they claim to be, and they have access to it. Until then, no thank you, sir. Least privilege, something as touching upon previous. Make sure that the resources who try to access any sensitive stuff, they have the bare minimum privilege to access those. And anything, even one level above that privilege that is required for them to function, they should not have access to it. An example of the implementation can be scoping out your APIs. You say, OK, this API is basically for creating a user. So whatever API token that you have, it should not have the privilege to delete the user or maybe access information related to other users or other customers that you have. It should just correspond to whichever user the API key is associated to. And separation of duties. That means any specific service that you have should only be able to do that specific task and not delve into the domain of other tasks. That helps in making sure that whatever access-related stuff that you have, those are applied to only those services or users that you need access to. Testing, SAST and DAST. So static code and dynamic code testing. Test extensively, test regularly, and do penetration and third-party testing to make sure that you do not have any missing links. Any stuff that you may have missed in your internal testing can definitely be caught by an external audit, by an external tester. It just helps rule out stuff, helps rule out any potential events that may occur in the future. Defensive in depth. So that essentially means multiple layers of security. So let's say that you have a castle, right? You have a lot of protected gold in that. So you add multiple layers to securing that gold. You first add a moat there so that any army or invaders are not able to access that, and not able to get into the castle. But once you cross that, once anyone is able to cross that, you still want to put in more controls, right? You want to probably add a door, a lock on the door, lock on the cabinets that are storing the gold. Same thing with security. You basically have to put authorization and authentication at the application layer as well as the infrastructure layer. That allows you to make sure that whoever is getting through your doors, they are who they claim to be, whether it be services, whether it be users. And MFA always helps. Code review. An often overlooked aspect of secure coding is just review, making sure that you do extensive code review before any service or any code goes to production. So something common stuff that you can look at while doing code reviews, open redirects, often overlooked. Not doing enough or improper input sanitization. Using vulnerable libraries. Lower grade or encryption or hashing. So let's say that you're using SHA-1 in this environment, in this day and time. It's pretty old. Or you're not even using hashing. If you're storing your passwords in plain text, storing your APIs in plain text, that's a strict no-no. That can all be caught during code review. And improper integrity checks. So that means that whatever communication that you're sending across, there needs to be an integrity layer where whoever is receiving that makes sure that nobody in the middle has modified that information. So that integrity check needs to be proper. So this is, if you're able to see the code, this is a code that got into Google Cloud, and somebody pointed it out. It's something as simple as basically it's trying to assign a user role, update a user role for a user. And the code has a bad condition in it. If you're able to read the code, and if you see the line number 12, it says that the email address, if the request has an email address or a user has an admin role, then you update the role. So basically, any request that comes to it which has an email address will have an admin role. Now, why? Because there is an OR condition instead of an AND condition. Something as simple as this could have been easily caught in a code review. But that got into Google Cloud, for that matter, right? Patch libraries. So touching up upon that log4j, so something as simple as updating libraries regularly, that can be caught during static code analysis that you do regularly. So any libraries that are vulnerable, that are pointed out, that have active open CVEs, those, and especially those with a very high CVE score, those should definitely be addressed at the earliest. And yeah, that'll help you maintain a better security posture. So what have we learned? So secure code and application security is definitely important. It is something basic. It is something not rocket science. Some very simple basic steps can go a long way in making sure that your application, that your security posture is good. And we covered a few basic security practices. Any questions? That was my presentation. Any questions that anyone has? Please make sure that you use the mic in the middle of the room. That will be easier and for me to answer. Anyone? It wasn't that simple, right? Anyone? OK, all good. So there's one feedback slide. If you have any feedback for me, please. Oh, go ahead, please. Can you go in the middle? It's a little hard for me to hear.
Hello.
Yeah, go ahead.
So in your slides, you mentioned we should perform like unsalting of hash functions. So what do you mean by unsalting of hash functions?
So that you do not add in random assault to your hash, basically. So basically, you're hashing that string or whatever your user input is, but you're not adding a randomized salt to it. That makes it easier for an attacker to sort of like brute force the hash using rainbow tables and all.
Okay. So like, what is the salt you mentioned again?
Salt is a random string that is assigned to it so that it's easier for you to prevent guessing of the actual input and then comparing the hash.
Okay. Yeah. Thank you.
All good? Perfect. OK, great. So I'm guessing no more questions. So if you have any questions outside the session, I'll be over here throughout the 2 days. And I hope you all have a very good Identity Shield 2024. Thanks a lot. You've been a great audience.